life on Earth is an incredible experience. Indeed, life itself is incredible. And the human being, at the pinnacle of it, is so complex in its design and its operation that we have barely scratched the surface in understanding it and its significance, even at the small biological level of our procreation. Our part in the creative process is physically so minuscule that it is barely worth the mention. We do our little part, and even this itself is impelled by impulses that we merely react to. And once our little deed is done, the rest unfolds automatically, almost beyond our control, and largely beyond our understanding of it. Then, 9 months later, a new human being inhabits the earth who is eager to learn, to discover, and to develop itself. We call the offspring our children, as though we had made them, while in reality we had almost nothing to do with the incredible process by which humanity continues to exist. It would be far more correct in this light to regard all children as the children of our humanity, and ourselves likewise, and to care for the children and for one another accordingly, universally. A few years down the line, the child begins to discover itself in the context of its larger world that it is a part of. And in times after that, the child becomes an active participant in the dynamics of human living, with all its wonders, inasmuch as its understanding will reach. As grown-up adults, humanity begins to understand its history, and with it begins to open its eyes towards its future, both its individual future and, to some degree, the future of humanity as a whole. This happens as society begins to open its inner eyes to the unseen dynamics of the world, which only science can bring to light. Here a vista unfolds of what we have become. The human species has developed from its distant beginnings almost entirely during the Pleistocene epoch in geologic history that spans roughly 2 million years. The Pleistocene is also the epoch of the modern ice ages. Less than a quarter of it is shown here. Throughout this epoch, for 85% of the time, glaciation conditions had gripped the Earth, which were interrupted only briefly, with warm climates of short periods, roughly 12,000 years in duration, occurring in roughly 120,000-year intervals. What we call history in modern times is the most recent part of the human journey that has occurred almost entirely during the current interglacial period that followed in the wake of the last ice age. This brief holiday from the cold, in which everything that we term civilization was developed, which has spanned slightly over 12,000 years to date, is represented by the expanded view. All that we have become, what we are today, has been developed in this relatively short period. Halfway through the period, the now common written languages were developed. Later in the period, for which the time frame is shown expanded again, around the little ice age of the Mount Minimum, many of the great developments in science began. In this period of the Little Ice Age, around the Maunder minimum in solar activity, some of the great scientific geniuses had their day, whose contributions have lifted the face of civilization. There we find Johannes Kepler uplifting science, and Bach and Mozart and Beethoven uplifting music, and so on. The Little Ice Age itself was but a ripple on the larger climate horizon, as was the recovery of the sun that broke us out of the Little Ice Age and gave the world one last taste of the congenial climates in which humanity grew up. The most recent period, the period of the global warming, that got us out of the Little Ice Age, is shown expanded again for its more immediate importance. In this last part we find the dawn of the Industrial Age and the age of large-scale energy utilization, the age of technologies, air transportation, giant cities, and advances in agriculture, which together enabled our minuscule human species to increase its presence on the earth 1,000-fold beyond what the natural world had once been able to support with its rather meager natural resources. The big breakout in the power of human living began in the 1800s. It started with the recovery of the sun and lasted till around the year 2000, when the modern climate reversal began. The big open question in this is whether the solar reversal after the year 2000 can be seen as the beginning of the end of the interglacial period. The interglacial periods typically begin sharply and end sharply. That's what the ice core records convey to us. They tell us that our current interglacial was a wonderful holiday under a brilliant sun that is about to end, that we've taken for granted and still do so because this is all we have ever known and experienced. This means that the 15% portion, the slim interglacial spike, that is all that we have ever known, is now fast ending for reasons that it is a climate anomaly in the overall context and is not representative of what is normal. The problem is that it is hard for us to imagine that what we have believed to be normal is as fleeting as a puff of smoke blown into the wind, after which the actual normal world resumes, that ice core measurements tell us may be 40 times colder than the Little Ice Age had been. Humanity is totally unprepared for living in an Ice Age world. Most people live outside the tropics, above the 23-degree latitude. These higher latitude regions promise to become rapidly uninhabitable, possibly in less than a single year. The blue line is the permafrost line that was established during the previous Ice Age. We have built our world around the basis of the present warm climate. We have established great cities and cultures in these areas where soon no one will be able to live anymore, much less grow food there. How then can humanity survive when the Ice Age phase begins anew? The physical option for the survival of humanity is simple. It is as simple as all the nations that live outside the tropics to relocate themselves into the tropics, which means building 6,000 new cities for 1,000,000 people each, complete with new industries and new agriculture. This means that most of the new infrastructures, including the cities and agriculture, be placed afloat onto the sea for the lack of suitable land in the tropics. The technologies for building the new infrastructures do exist, and so do the materials and the energy resources. But do we see anyone moving on this vital front to get the job done or even started? We see nothing moving there. That's where the big problem lies. It lies in us, in humanity as a whole. It lies in the lacking recognition of the principles that govern the dynamics of our world, and the motivations that govern ourselves in respect to what we know. Sure, we have created a specific type of science for exploring the solar dynamics. We have created the science of astrophysics for this, the queen of the sciences. Unfortunately, as it is so often the case, the queen of the sciences is not free, nor has it been free for most of its history. For a long period, since the days of Ptolemy, the science of astronomy had its course dictated by religion. It was said in those historic times that all the orbits of the heavens must follow the path of perfect circles, because with the heavens being perfect and the circle being a perfect geometric construct, no other option is theologically possible. However, because the observed evidence didn't match the doctrine, fudge factors needed to be invented to bring the evidence into line with the doctrine. Astronomy is still stuck in this trap. In Ptolemy's time, the invented fudge factors were the imagined epicycles and the imagined equant. The inventions for this self-deception were so well done that astronomy became self-imprisoned by them for 1,700 years. The epicycles and the equant had kept astronomy chained to a false concept for all this time, until the astronomer Johannes Kepler stepped away from the doctrine, looked at the evidence, and subsequently discovered in the process of honest looking at the relatively obvious, the orbital dynamics that reflect the physical principles of mass, velocity, and gravitational interaction. With Kepler's discovery, by simply looking at the evidence that tells its own story, a new freedom opened up in astronomy. Nevertheless, modern astronomy is still trapped into the mysterium of imposed doctrines, such as the doctrine of orbiting stars, that is completely impossible under the orbital laws that Kepler had discovered. In order to make the impossible seem plausible, new fudge factors have been invented, such as the supermassive black hole, dark matter, and dark energy, and so forth, which were once again, as of old, imagined phenomena that no one has ever seen, but are simply made up or inferred. Thus, astronomy still remains imprisoned under doctrines, by its own self-deception, instead of it looking for what is actually real and moves the universe. This simply means that the Dark Age hasn't ended, in which doctrines keep scientific perception in chains. Another imprisoning doctrine is called entropy. Entropy is a concept by which every dynamic expression in the universe is deemed to diminish towards a zero-energy state, like a wind-up toy or clock comes to a stop when the energy that has been wound up into its spring or supplied in batteries becomes exhausted. While the concept of entropy accurately defines these types of wind-up systems, it clearly doesn't define the universe, which everyone can easily recognize. The doctrine of universal entropy has been promoted with the invention of the Big Bang theory as a fudge factor that is designed to make the impossible seem plausible. The invented theory envisions a universe that was created in a primordial Big Bang, in which all the energy and matter was created, with which the universe is formed, and which is all that the universe will ever have, so that necessarily, the universe is on a path of winding down towards its ultimate death. A component of the Big Bang theory is the hydrogen model for the Sun. It envisions the Sun as a sphere of hydrogen gas that is compressed by gravity to such immense density that nuclear fusion occurs, in which hydrogen atoms are forged into helium atoms, in a process in which energy is deemed to be created that percolates to the surface and lights up the Sun to a brilliant sphere in the sky. The Sun is thereby deemed to consume itself as it burns its hydrogen fuel into helium. That's the theory. It completely adheres to the doctrine of entropy. But the theory is not true, is it? The visible evidence doesn't support the theory. Everyone has seen the evidence bright and clear that renders the hydrogen sun theory to be false, by simply looking at the sky when a rainbow appears. 7 distinct colors can be recognized in the rainbow, with numerous shades of them in between, in a continuous band of color without gaps and breaks. The same continuous band of color can be seen when the sunlight is passed through a prism. All the colors and the shades between them are contained in the sunlight, which are sorted out and separated by the prism according to their wavelengths. However, when one looks at the light that hydrogen gas is able to emit, in comparison with the sunlight, one sees only 5 narrow strips of light with nothing in between. 2 of the strips are so faint that they wouldn't even be visible in a rainbow. The simple evidence that one sees in comparison the sparse hydrogen light spectrum with the actual sunlight spectrum proves that the theory of the hydrogen sun is impossible, though it has become the near-universally accepted kind of doctrine. The hydrogen sun theory is impossible because it cannot produce the sunlight that we see. The evidence is so dramatic that Surely anyone would agree that the hydrogen sun theory is false. Can you recognize that it is false? One might ask a schoolgirl. Of course it is false. How could it not be false? The girl might answer. The difference between the light that the theory gives us and the light that the sun gives us is like night and day. The theory doesn't come even close. The theory is false, therefore, because the nature of the hydrogen atom is too primitive to produce the sunlight that we see. Our teacher told us in school that the hydrogen atom has only one electron, the girl would say. The teacher says that when an atom absorbs energy, its electron jumps to a higher orbit. But since it can't stay there, it snaps back, whereby the energy is retransmitted and flows away from the atom as a photon of light. With hydrogen having only one electron, the teacher says, it can produce only a few types of photons because there exist only so many higher orbital spaces that an electron can jump into and back from. This is why only 5 different colors can be emitted by a hydrogen atom in narrow strips. But if one was to combine the light that is emitted from a few different types of atoms, which all have different emission spectra, which in some cases also have many more of them, as in the case of uranium, that has an extremely complex atomic structure, as the teacher tells us, then the result would add up to something much closer to the full spectrum of the sunlight, though it still would not be quite enough. Open your eyes further, Johannes Kepler would say to the child if he was alive today. Combine in your mind not only the light spectrum of just 4 or 5 atomic elements. How about 94 of them, all emitting light together, each with its own array of spectra? Wouldn't their combination be sufficient to produce the sunlight that we see? The girl would nod in agreement. In this case, all the atomic elements would have to be energized together, right at the surface of the sun. But why would they be there? Wouldn't they all fall into the sun and vanish from sight, being heavier than hydrogen? Oh, they would be there, all of them together, if they were dynamically created there, right at the surface of the sun, Kepler would answer. All atoms in the universe are assemblies of electrons and protons. It takes a lot of energy to combine them into atoms. But in space, they exist in unbound form. In this form, they are termed plasma. Also, they all have an electric charge. In an atom, the charges are balanced and thereby neutralized. In space, the charges are dynamically mixed. Your teacher may have told you about that. This wasn't known in my time, of course, Kepler would continue, but it is known now. It is known that almost all of the mass in the universe exists in the form of plasma. At least 99.999% of it does so. Now, while the sun is evidently not a sphere of hydrogen gas, It is possible for the sun to be a sphere of plasma that attracts plasma from surrounding space. In fact, plasma is focused onto the sun in highly concentrated form. This plasma is literally forced onto it. The sun binds it up into bundles with the electric force and creates tightly knit atomic elements with it right at its surface, whereby the sunlight is created that thereby appears to be the sun's surface. Kepler might ask the girl, can you visualize with the power of your mind such an atomic synthesizing process happening right at the surface of the sun? If so, how would you know with certainty that what you see is true? I know it is true, the girl would answer, because I can see the truth with my own eyes. When one looks at the sun through the umbra of the sunspots that are holes in the shiny surface, the sun appears to be dark inside. It's plain for all to see, she would say. No one has ever seen anything different. I asked the teacher about it. He says that this is a subject that goes beyond the curriculum that he is allowed to teach. I was luckier in my time, Kepler would answer. In my time, during the 30 Years' War, everybody was busy killing one another. The exotic doctrines carried little weight then, for which the epicycles and fudge factors were invented. I was free to look at the universe honestly, Kepler would say to the girl. It was amazing what one begins to discover by becoming free to what unfolds in the perspectives of the mind. It becomes an incredible experience to experience oneself as a human being. What comes to light there is grander than the grandest landscape and the brightest rainbow. Nothing comes even close to that, just to be able to see this. I wrote my discoveries down in a book that I named The New Astronomy. I didn't care whether anybody would understand me for another 1,000 years. I knew that what I had discovered is the truth, and I was glad to share it. Well, it didn't take 1,000 years, the girl would answer. Your discoveries are now routinely utilized to calculate spaceflight trajectories. What you saw has timeless significance. This is why you should be afraid of your life, Kepler would answer back. The history books may tell you that I starved to death. I died in the fields out of weakness while searching for food for my children. Too much had been destroyed in the 30 Years' War. Too many people had been killed and farms burned to the ground. Food production had collapsed. More people likely starved to death than were killed in the war. I'm saying this because you still have a chance to avoid the same fate. But before you will ask me while I am saying this, let me ask you instead how secure our sun really is, as you now see it, which is a sun that depends on energy supplied from space. The girl would nod and answer a while later hesitatingly. Our sun cannot be a secure sun if it depends on external energy flowing to it from space. But how certain can we be that it is vulnerable? You should be able to answer this yourself, Kepler would say. Your teacher might have presented the answer in your physics class. It is a fact in basic physics that when an electric current flows in two parallel wires in the same direction, the wires attract one another by magnetic interaction termed the Lorentz force. While wires are typically held in place, the flowing electric plasma in space gets pinched together by the attracting electromagnetic forces, which thereby increases the electric density and the resulting magnetic field, which in turn increases the pinch effect still further. This goes on and on until the magnetic fields get all tangled up. At this point, the flowing plasma gets curled backwards and collects under a magnetic dome where it becomes further concentrated. Under the resulting pressure, the concentrated plasma escapes through the open hole and gets focused onto a sun, where it is consumed by the process of atomic synthesis on the surface of the sun. The girl begins to smile again. I can see what you're getting at, she interjects. When the interstellar plasma streams become too weak by the magnetic fields to become tangled up by the pinch effect, so that the plasma doesn't get flipped back and becomes concentrated, thereby to be focused onto the sun, then the plasma density around the sun becomes too weak for the plasma fusion to be possible on the solar surface, at least not on the grand scale that we have it now, which lights up the sun, so that the electromagnetic fields that focus the plasma may break down. The sun would go inactive then when this happens, whatever this may mean. Our familiar sun will then no longer exist in the way we see it today. It may become dim. No one has yet seen what the sun will then be like, Kepler might interject. But we can know this precisely, and long before it happens, because as human beings, we have the capacity to see with the mind far into the future by understanding the principles that govern the physical universe. Isn't it amazing what we as little human beings can be aware of? The girl might say. We can see what no bird or animal can as much as dream of. But we can see it happening in our mind as clearly as it was plainly visible and was happening right now, instead of in future ages. Wow, what an experience! That's better than riding the swings. By understanding the basic principles of the universe, we can see the future long before it happens, in all critical details. Is this really possible? It would be the most incredible experience of them all, the girl would add. Not would be, but is, Kepler would reply. All this is possible, because it is possible for a human being to see the physical future of the world by knowing the principles that shape it. It is as profound and as simple as that. All this is made possible by the power of the mind and the power of technology and scientific knowledge. You should know this too. You have knowledge at your fingertips that no one would have ever even dreamed of in my time. I was fortunate in what I did, Kepler might add, because I had an extensive set of accurate astronomical measurements prepared for me by Tycho Brahe. I simply took his measurements, looked at them, and in the process of looking at them with the mind's eye, it became evident to me what was really going on. Then, once I saw the answer that had evaded astronomers for 15 centuries, and knew that what I saw is true, I stood on the same ground that the slave boy had stood on in Plato's Meno dialogue, who had discovered the principle for doubling the area of a square, and could say in the end, with absolute certainty, that what he discovered is correct, by simply looking at the visual evidence. The slave boy in Meno's dialogue is guided by Socrates to discover the principle for doubling a square. He is guided to create a new square that is 4 times as big as the original square, and then divide each of the resulting 4 squares in half along the diagonal, which results in a square created by the diagonals that is twice as big in area than the original square. The slave boy could look at the result and say with absolute certainty that the resulting square is twice as big in area as the original square by simply counting the triangles as evidence. He could see the evidence reflecting the principle. He knew the result to be true. Kepler would add, saying to the girl, "You can experience today the same certainty in seeing the future before it happens, on the basis of the principles that you now know, and by seeing the reflection of these principles in measured historic physical evidence. You have an amazing amount of measurements available to you from the big ice coring projects that were completed around 2003. You can see in them the principles reflected that you have come to understand as demonstrably truthful. In the big Greenland ice cores, you have evidence measured for you of large, steeply rising climate oscillations from deep glacial conditions all the way to the near interglacial conditions and then back again, occurring in intervals of 1470 years, called the Dansgaard-Oeschger oscillations. Some of these oscillations were up to 40 times larger than the cooling that had been experienced during the Little Ice Age in the late 1600s, that had even then devastating effects for many people. Are you saying that the sun going inactive for the next ice age is not just a theoretical possibility, but is going to happen with the same certainty with which the slave boy in the Meno dialogue knew that he had doubled the square? The girl might interject. Is this what you meant when you said that I should be afraid for my life? Did you mean this as a consequence of the sun going inactive? Kepler would nod. What we can see as the expression of universal principles is real. The coming ice age with an inactive sun is real. The harsh consequences that result take astrophysics out of the academic domain and into the real world. Yes, my dear, you should be afraid of losing your life, because you will starve to death with absolute certainty if the infrastructures are not built for continuing agriculture under an inactive sun. We are on the path already. The great phase shift to the next ice age is already in its pre-stage. We are moving towards it. It will happen as a sudden event, possibly in the 2050s. There are resonance cycles happening in all the big plasma streams, like the resonance cycles of your swing set. We can see their effect. When the big cycles come together at their minimal point and interact, big effects happen. The timing is predictable, and the consequences are predictable too. The plasma sun is losing steam. NASA's Ulysses spacecraft saw the beginning of it. The plasma density is fading fast. In its inactive state, the sun will diminish and likely become a red star, as the inactive stars are called. In its inactive state, the sun won't support agriculture as it is known today, even in areas that are not covered in ice. Your NASA's Ulysses spacecraft has measured a 30% drop in solar wind pressure in the short span of just 10 years, ending in 2008. That's huge, Kepler would say. At this fast rate of fading out, the solar wind may cease to flow altogether in the 2030s. The sunspot cycles are likewise diminishing at roughly the same rate, which means that the solar activity is diminishing. The fading solar wind reflects that. This is all clear evidence that the plasma streams that are focused onto the sun are dramatically weakening. Does this mean that the sun could go inactive any time after the 2030s? The girl would interject. Does anyone realize what this means? That's the wrong question, Kepler might answer. The big question is, do you know what this means? Are you willing to make the effort to assure that you will live? Are you willing to do whatever it takes? The phase shift may not happen before the 2050s. It leaves you 30 years to get the job done, which is not much time for the nations of the world to relocate themselves into the tropics, Kepler might add. You ask, does anyone realize what this means? The answer is yes. A human being can see precisely what this means, though few people presently recognize themselves as such. You yourself may not see precisely what happens when the primal fields collapse, or only one of the nested primal fields collapse that focus plasma onto the sun. You understand the principle to some degree. You have an inkling of what happens when the principle is no longer expressed. At this point, many potential events could happen. It might be that a plasma fusion on the sun will then no longer be possible and stop. The photosphere might vanish. In this case, previously created atomic elements would no longer flow away, but fall back onto the sun. They would fall deep into the sun until their atomic structure would become crushed. This could happen. In this case, the invested binding energy would be released in nuclear fissioning. Do we see evidence for this happening? Do we see the red dwarf stars as evidence for that? Evidence exists that 3/4 of all the stars in our galaxy are presently inactive stars of the red dwarf type. This adds up to 300 billion inactive stars. But is our sun destined to go this route and become a red dwarf? Or will the sun, when its closest primal fields become inactive, simply continue on with a lower intensity plasma fusion and a lower surface temperature of the kind that we see in the red dwarf stars? These are the questions you need to ask. And keep on asking and asking until you know with certainty what the future of the sun will be. Kepler would have been right had he said all of this. 2 major types of stars have been discovered to exist in our galaxy, named the Milky Way galaxy, which contains an estimated 400 billion stars. One of these is the inactive type, the red type. Most of this type are of the red dwarf type. An estimated 75% of all the stars in the galaxy are of the M category, the low surface temperature category. The red dwarf stars dominate this category. They come in different sizes, but are typically so small and so dim that they are hard to detect. Johannes Kepler would not have seen them. Even the Hubble Space Telescope can see them just barely. The image shown here is of the closest red dwarf in the stellar neighborhood. It is a part of the nearest solar system, named the Centauri system. It is located a mere 4.2 light-years distant. The number of red dwarfs in the galaxy has been estimated by what has been observed in the stellar neighborhood. The Hubble image indicates that the red dwarf is surrounded by a cloud of atomic elements. This is what one would expect to see for an inactive star that attracts gravitationally the previously synthesized atomic elements, which no longer flow away with the solar wind. They would emit light by their interaction with the plasma of the original star. The light would increase in intensity with the increasing gravitational pressure in the plasma of the star towards its center until the atomic elements would fission and light up the central sphere. The red dwarf might also be simply a small star that is powered by less intense plasma fusion with a lower surface temperature and lesser solar winds, so that the synthesized atomic elements form a haze around the star. Is this what we see here? Is this the destiny of our sun? The effective surface temperature would be significantly less if our sun would be powered by a low-level plasma fusion process. Its surface temperature would then be of the category M type at 4000 degrees Kelvin or slightly less. This would be enough to shift the climate into the deep glaciation conditions that we had in the previous glaciation period that we call the Ice Age. In this case, the sunlight spectrum would be shifted to a lower profile, but would remain in range for the chlorophyll to work. The effect will likely reduce the radiated energy that we receive on Earth down to a mere 30% of what we receive today. It promises to have huge consequences. The small size of the world population at the end of the last glacial period, which is estimated to have been in the range of 1 to 10 million, indicates that living is possible in the tropics under this type of inactive sun. But it won't be a picnic by any means. Food resources would have been sparse during the last ice age, perhaps consisting mostly of fish. It is possible for 7 billion people to live under such harsh conditions and to live richly. But this is not possible on the natural platform that can support but a few. It is only possible on an artificially created, energy-intensive, high-technology platform operating in the tropics, interwoven to some degree with large indoor agriculture in artificial environments and with artificial lighting. These infrastructures can be easily created in automated high-temperature industrial processes, together with thousands of new cities and new industries, most of them becoming located afloat across the equatorial seas. In the course of the implementation, a completely new high-temperature industrial revolution would unfold, with basalt as the feedstock. It would revolutionize economics, and with free, high-quality housing and public facilities, it would revolutionize culture in every respect. We could create the brightest renaissance under an inactive sun. But will we raise ourselves up to that level and become human beings in the highest sense that our humanity enables? Will we grasp the only option we have and live? I think we will, and we will do it before our sun joins the rank of the 300 billion inactive stars in the galaxy. That the red dwarf stars are inactive stars becomes evident by comparison. Active stars are typically surrounded by a large blue atmosphere, perhaps of highly activated hydrogen, whereas the inactive stars tend to be surrounded by a darker, more reddish glow, perhaps of less activated hydrogen. The active brilliant stars are thereby, as by their nature, of an entirely different class. The stars are classed by luminance into 6 categories that can be grouped into 2 groups. One group contains the really active stars, type A, B, and O, with a surface temperature ranging upwards to 60,000 degrees. The star Fomalhaut from the previous image is located on the low end of this group. The group of extremely active stars is small in numbers. About 3 billion stars belong to this group. These brilliant stars are most likely the ones to be observed by the automated star mapping systems that observe hundreds of thousands of stars simultaneously. The other group combines the lesser brilliant stars. This group contains the Sun of the Earth. It contains the stars with a slightly lower to slightly higher surface temperature than our Sun. There are around 90 billion stars in this group. These lesser, still active stars, like our Sun, tend to be more vulnerable to going inactive and becoming red stars, though being less bright. They are not of the type that is routinely observed by reasons of their large numbers and their comparatively low luminosity, so that no one would likely notice individual stars of this group going inactive. And if so, the observation would then most likely be recognized as noise in the system, since inactive stars are deemed impossible under the hydrogen-sun theory. It is highly unlikely, therefore, that when such stars go inactive, when they revert to a lower surface temperature, that the event will be noticed or be reported. The mainstream cosmology has no basis for recognizing inactive stars. In mainstream cosmology, every star, small or large, is deemed to be a hydrogen star that cannot go inactive, for reasons of it being lit up with nuclear fusion occurring within it. This theory still rules the world, regardless of the fact that a hydrogen sun cannot produce the seamless band of color that we see in the sunlight. The theory also still rules, contrary to the obvious fact that our sun, as a sphere of hydrogen gas, would be 1,000 times heavier than it actually is in comparison with Jupiter and Saturn. Nor would a sphere of hydrogen gas, the size of the sun, be able to exist, as the resulting intense gravitational force would crush all atomic structures in its core. In order to rescue the hydrogen sun theory, the concept of electron degeneracy had been invented that supposedly interacts gravitational pressure acting on atomic structures. The theory supposedly enables the compression of the hydrogen gas at the core of the sun to a 200 times greater density than water, without the atoms becoming crushed. The hydrogen sun theory becomes even more impossible when one considers the existence of giant stars, like the star UY Scuti, that is 1,700 times as large in diameter than our sun is. A gas sphere of this gigantic size can evidently only be upheld with magic. A sphere of plasma, however, of this immensely huge size, would be able to exist quite naturally. It would be upheld by the repelling force of the protons in plasma. The electric force is one of the strongest forces in the universe. It is 39 orders of magnitude stronger than the force of gravity. With the plasma sun concept, for which the stars themselves stand as evidence, the impossible paradoxes that pervade mainstream cosmology fall by the wayside. No magic is required in the real world, or epicycles or fudge factors. The mainstream cosmology champions a number of impossible paradoxes that are routinely explained away with magic. For example, no physical principle exists outside the plasma cosmology for the solar planets to orbit their sun in a tight ecliptic plane, as they do. Exotic causes are cited for this in mainstream cosmology. Likewise, no physical principle exists in mainstream cosmology that would force the stars in a galaxy to align themselves into the thin ecliptic disk formation that we behold. In plasma cosmology, the phenomenon is recognized as a basic electromagnetic phenomenon that has been replicated in laboratory experiments. No magic is active there. In addition, in mainstream cosmology, all the stars of a galaxy are deemed to be orbiting the galactic center. This is an impossible concept that Kepler's laws of orbital mechanics render totally impossible. But why should anyone care about that? In mainstream cosmologies, the impossible happens by magic, wherever required, to keep the doctrines satisfied. In this case, the impossible is deemed to be possible by the application of the magic of supermassive black holes, dark matter, and dark energy, which no one has ever seen or can see, and are not even theoretically possible. This means that what we see expressed in the stars reflects a totally different operational platform in plasma cosmology. In plasma cosmology, stars can go inactive, and apparently have done so, even among the big stars. Going inactive, of course, doesn't mean a complete turn-off, but means instead that their potential high-intensity state no longer happens. The famous Hertzsprung-Russell star data diagram is arranged by the star's surface temperature from right to left. The grouping of stars is shown here, arranged from M on the right for low-temperature stars that include the red dwarfs, all the way to O on the left for the super-intense high-temperature stars that have a surface temperature of up to 60,000 degrees. At first glance, it appears that a linear progression exists, whereby the larger stars are inherently hotter stars. The progression holds true up to a point. In the sequence of comparison of progressively larger stars shown here, only two intensely active stars appear after the Sun, with the remaining types standing as examples of what one might term inactive stars. Of the active stars, the star Sirius in panel 3 stands as an example for a range of active stars that are larger than the Sun and have a higher surface temperature. The Sun has a surface temperature of 5,800 degrees Kelvin. The larger stars exceed this. The star that is closest in size to the Sun is the star Fomalhaut. It is 1.8 times larger in diameter than our Sun and has the correspondingly higher surface temperature of 8,500 degrees. The star Sirius, in turn, is twice as large as the Sun and has a surface temperature of 9,900 degrees, almost twice that of the Sun. For the star Spica A, which is the larger star of a dual star system and is 7.4 times as big as the Sun, the measured surface temperature is a whopping 22,400 degrees. A principle appears to be reflected in this progression between the size of stars and their correspondingly higher surface temperature. The progression in temperature seems to indicate that larger stars are able to attract larger volumes of interstellar plasma, which electromagnetic fields focus around them, which the stars consume in surface plasma fusion. The focused plasma becomes more concentrated around the larger stars, by the larger stars having a greater electric and gravitational potential, which all play a role in the plasma fusion dynamics. The progression breaks down when one considers the still larger stars, Arcturus in panel 4 and Aldebaran. Both stars are larger in diameter than the stars in the group represented by Sirius. The star Arcturus is 25 times larger in diameter than the Sun, but is a cold star with a surface temperature of only 4,200 degrees. The same is evident for the star Aldebaran. Aldebaran is 44 times larger in size than the Sun, but achieves only a surface temperature of 3,910 degrees. The progression in surface temperature by size is broken by these two examples, as if the part of the dynamics that causes intense solar activity no longer functions past this point. Instead of Arcturus, by its being larger in size, having a still higher surface temperature than the 22,400 degrees of Spica A, Arcturus is much colder, and Aldebaran even more so. The break in the progression suggests that a systemic failure has occurred in these cases that enables only a lesser type of plasma fusion to occur. For the Sun, the high-density plasma compression, which enables its 5,800 degrees high-temperature plasma fusion to happen, appears to be the product of a threefold nested system of primal fields. If one of the three stages of the nested primal fields would fail, the result would be a much reduced plasma pressure around the Sun and a much reduced plasma fusion activity occurring on its surface, with a much lower surface temperature being the result of it. The concept of a threefold nested system of primal fields is difficult to illustrate and to visualize, but evidence for it does exist. For the stars Arcturus and Aldebaran, one of the stages may have broken down as the result of the diminishing plasma density in the galaxy, or may not have existed. It evidently takes a lot of plasma to power a large star like Aldebaran to its full capacity. Also, the plasma density may vary regionally across the galaxy. We have evidence for that too. The low surface temperature of Arcturus and Aldebaran is not necessarily typical for large stars. The exception is the star Rigel that we find in panel 5. This star is 3 times larger than Arcturus and almost twice as large as Aldebaran. It should be a dim star by its size in comparison with Arcturus and Aldebaran, but it isn't. It is intensely active, though not quite as active as it should be for an active star of its size. The giant star Rigel is nearly 80 times larger than the Sun and has an estimated surface temperature of 12,000 degrees, located at a distance of 880 light-years from us. Rigel proves that giant stars can be highly activated stars if the plasma density exists. For Rigel, there might not be enough of it. A fully active star of its size would have a surface temperature of 50,000 to 60,000 degrees. Quite a few giant bright blue stars do exist in the galaxy. Sometimes they are referred to as blue stranglers. In the classification by surface temperature, the giant active star Rigel is of the B class of roughly 500 million stars. The O class of stars with a surface temperature exceeding 30,000 degrees, typically in the range of 65,000 degrees, is extremely small. Only 20,000 stars of this group are believed to exist in our galaxy. They are typically found at the center of a nebula. Their luminosity is several million times that of the Sun. In the 2 examples of Class O stars, the atomic material that make up the nebula are evidently the plasma fusion products of the superactive supergiant star. The atomic elements in the nebula emit light by the interaction with the plasma flowing in the sphere of the nebula, typically in the form of solar wind and interstellar plasma flowing through the nebula. The O-class star that has created the nebula, shown here, shines bright and clear across 5,200 light-years of space. But not all giant stars are of this category. Many of the giant stars are inactive stars. All the giant stars that are shown here from Antares on in panel 5 to the supergiant UY Scuti in panel 6 are inactive stars. While these stars span a large range in size, they share one common feature. Their surface temperature is cold, in the range of 3,000 to 4,000 degrees, which is also the typical surface temperature of the red dwarf stars, a type of default temperature. For example, the main star of the Antares system, Antares A, is a supergiant star that is 880 times larger than the Sun, but has a surface temperature of only 3,400 degrees, which is typical for inactive stars. It is so dim that it is barely visible across its 550 light-years distance. Antares B, in comparison, which is an active companion star, is only 5.2 times as large as the Sun, but has a surface temperature of 18,500 degrees. That is typical for what may be termed active stars. In the image shown here, The size of the smaller Antares B is dramatically exaggerated, perhaps to illustrate the visual difference between an active and an inactive star. In its active days, Antares A might have been a superstar. Antares A is 300 million kilometers in diameter. Its huge size dwarfs the Sun, but because of its low surface temperature of 3,400 degrees, as an inactive star, the giant star is only 100,000 times as luminous as the Sun, with a dim red hue, instead of the millions of times greater luminosity that it might have once had as an active star. Antares A is 300 million kilometers in diameter. Its huge size dwarfs the Sun, but because of its low surface temperature of 3,400 degrees, as an inactive star, the giant star is only 100,000 times as luminous as the Sun, with a dim red hue, instead of the millions of times greater luminosity that it might have once had as an active star. Antares might be an example for a star burning by nuclear fission drawn from its surrounding. It might also be an example of low-level plasma fusion happening in a low-density plasma environment, in which the synthesized atomic elements hang around the star like a cloud. In this sense, when our own Sun goes inactive, with which the next ice age begins, it would remain powered by interstellar plasma, but in a radically less compressed form around it. The Earth will not lose its Sun then, when the Sun goes inactive, but have a cooler, dimmer, and more diffused Sun, with a surface temperature of roughly 4,000 degrees Kelvin. Much the same can be said about the hypergiant star UY Scuti that stands out brightly in the star fields across a distance of 9,500 light-years. This star makes the term gigantic seem small. It has a diameter of 2.4 billion kilometers, but its surface is cold. Its surface temperature is a mere 3,300 degrees. That is typical for a star being lit up by low-intensity plasma fusion or by nuclear fission. It is the star's enormous size that makes it 340,000 times as luminous as our Sun, even while it is technically an inactive star. As an active star, it would have millions of times the luminance of our Sun. Its surface temperature would then be exceeding 50,000 degrees. In this context, the star Rigel may be at a borderline. The plasma density around it is probably too low to enable its full potential. But after that, each of the large stars that stand as examples here are completely inactive, with all of them being powered to nearly the same temperature, regardless of their size, either by low-level plasma fusion or nuclear fission, or both. When our Sun goes inactive, with its surface temperature becoming reduced from the present 5,800 degrees to the 4,000 degrees range, a 70% reduction in radiated energy would result that would be similar to what we see in the umbra of the sunspots. The reduction would make the tropics slightly colder than the regions at the 70-degree latitude presently are. Some form of outdoor agriculture would likely therefore be able to continue, but maybe with enhanced lighting. In practice, a large portion of the agriculture would have to be carried out in indoor facilities with artificial environments, artificial sunlight, and artificially enhanced CO2 density, and so on. This is in essence what the stars are teaching us. What we see in the stars illustrates to some degree how deeply the plasma density in our galaxy has diminished. We presently experience the consequence of the long ongoing downramping of the plasma density in our galaxy that we have evidence of. The downramping began roughly 100 million years ago. The galaxy that we see today, with its vast array of inactive stars, is the result of the massive downramping in the galaxy. The measured long-term climate variations on Earth appears to be representative of the cyclical plasma density variations in the galaxy, and those variations are big. 2/3 along the downramping to the present state, Antarctica froze up, then thawed out again when the shorter cycles peaked, and then a few million years later it froze up once more and has remained frozen. These are huge climate effects on the Earth. They are evidently the result of huge gases that affect the entire galaxy and the stars within the galaxy. Stars going inactive appear to be the natural consequence of the long-term downramping in the galaxy. Our Sun is caught up in the dynamics of the presently diminishing galactic system. The resulting effects are obviously large, which we cannot escape from, but which we can adjust our living to. When our Sun goes inactive, its operating photosphere will likely become transformed to a lower intensity state, rather than vanish as the innermost primofields collapse that focus high-density plasma onto our Sun. Most likely, we will see the photosphere simply go dimmer, and the space around the Sun become fuzzier, as the solar winds won't sweep the synthesized atomic elements away as efficiently as they do now. Some form of solar wind will likely continue after the photosphere transforms itself. Should the photosphere vanish completely, the previously synthesized atomic elements would no longer flow away with the solar wind, but would fall back onto the Sun by gravitational attraction. When the attracted elements fall deep into the Sun, a point will be reached when the increasing gravitational pressure will crush the atomic structures of the attracted elements. In the resulting nuclear fission process, the previously invested binding energy would become released. The released energy would create a luminous fuzzy shell within the original plasma sphere. Both potentials are possible, though at the present stage, the nuclear fission potential is extremely unlikely. The Hubble Space Telescope has provided us a perfect photograph of a very small red dwarf star in the closest solar system to our own, the Centauri system, which is a mere 4.2 light-years distant. Is the tiny sphere that we see here of one of the smallest of the red dwarf stars, a sphere where nuclear fission takes place. We see the star surrounded by atomic material that glows dimly in the star's plasma sphere. Or do we see in this image an example of a tiny star that is powered by low-level plasma fusion? Most likely, that's what we see. However, the existence of the nuclear fission-powered stage of a star cannot be ruled out, regardless of its original size. Our galaxy is a tangled network of a vast array of plasma streams that are always in motion and twisting in the spiral arms by the principle of the Birkeland currents. When a star loses its connection to the interstellar plasma streams, its plasma fusion stops. Nuclear fission would then be its only energy source that the star would have, until the star would be reconnected again with the galactic network of plasma streams. In this disconnected state, the nuclear fission process would render the deactivated star dark and smaller in apparent size than its original size, and entropic in nature. Any star that is not externally powered is inherently entropic. The entropic dim star would then continue to consume the atomic material that it has created earlier during its active state. And when all of that would have been consumed, the dim star would become a white dwarf star. The white star stage might be reached in some places. Some areas in our galaxy have quite a few of them. Our sun might have been a disconnected white dwarf once around 700 million years ago, when, as it has been theorized, the Earth froze up completely and had remained a snowball for a few tens of millions of years. That's just a theory. Examples of white dwarf stars are encircled in this image. The pinprick of light appears to be cast by a type of synchrotron radiation that emits light under conditions of extreme plasma pressure, without any atomic elements being involved for the emission of light. In mainstream cosmology, the white star is regarded to be a burnt-out star, past the helium stage, that has lost thereby its ability to maintain its nuclear fusion process within. It is believed that electron degeneracy then allows the atomic material to condense, and with it, its remaining thermal energy. It is believed that the white dwarf is as dense as all of the mass of the Sun, packed into the sphere of the Earth, which then would glow brightly until it would cool into oblivion. Of course, the electron degeneracy is just a theory that, like an epicycle, is needed to uphold the hydrogen sun theory in the first place, which has become a doctrine in modern time that stands like a giant in denial of the plasma cosmology concept that is actually supported by a large body of evidence. Another form of white dwarf star is also possible in plasma cosmology, in a different manner, which may be what is actually being observed. The mysterious white dwarf star might simply be a brown dwarf star that exists in a region of high-density interstellar plasma in which it becomes an active star. This possibility is the most likely one that we see evident here. Evidence for such a case exists in the Gliese 229 binary system. In this binary star system, we have a brown dwarf star operating a red dwarf star. It illustrates the principle of orbiting stars. The large red dwarf in this example is the parent star, Gliese 229a. It is 69% as large in diameter than the Sun, and it is 59% as large in mass, with a surface temperature of 3,600 degrees. The small companion star, Gliese 229b, in comparison, is roughly the size of Jupiter. It is a mere 10% of the size of the Sun. Its low-level plasma fusion generates a surface temperature of less than 1,000 degrees. Here a problem would begin. If the small brown dwarf star did not have the gravitational pressure within it to cause the fissioning of the atomic elements to happen that it attracts, and would surely attract in close proximity to another star, which in part it would also synthesize itself. As a consequence, the atomic elements would accumulate within such a star, which would render these stars extremely high-density stars, which they are. The small brown stars are believed to contain 50 times more mass than the planet Jupiter. Such an extremely dense mass in atomic elements would cause the star to eventually fission in a supernova explosion. But this doesn't happen. The reason is inherent in plasma physics. In the case of a high-mass brown dwarf star, like WISE 1828, that may have 50 times greater mass than Jupiter, contained in the volume of Jupiter, the star would have a mass density that is 12 times greater than that of the Earth, which has the highest mass density of all the planets. The comparison renders the brown dwarf star many times denser than lead, even denser than uranium. How is this enormous mass density possible for such a small star? In atomic physics, this type of tight packaging would be a miracle that is not possible by any means. But in plasma physics, this extreme mass density is possible and is evidently quite natural. More than 1,800 brown dwarf stars have been identified in our stellar neighborhood. They are too small and numerous to be shown here. The reason why it is possible for these high-density plasma stars to exist can be recognized when one explores the inherently low mass density in atomic structures. An atom is a dynamic structure in which the swarming of electrons around a nucleus neutralizes the repelling force of the electric field of the protons at its center. The resulting packaging gives the atom a specific mass density. That the resulting mass density in an atom is extremely low becomes apparent when one considers that an atom is typically 100,000 times larger than the sum of its parts, which are the protons and the electrons that form the package. In plasma, however, which is made up of protons and electrons in free-roaming form, The electrons are not energized enough to perform specific functions. They simply remain free-flowing. In unbound plasma, of course, the protons all repel one another by the electric force of their equal polarity. The repulsion, however, is counteracted by the electric force of the electrons that have the opposite polarity. When the electron density in plasma is high, all the plasma particles can exist together much more tightly packed than in atomic formations. This principle enables the tiny brown dwarf stars to have an enormous mass density. Another similar case of a tiny star orbiting a large star, in this case an extremely active star, is the case of the star Sirius. We see a tiny star orbiting the large star. The tiny star shines brightly in the dense plasma environment that powers the large star. This tiny pinprick star is regarded to be a high-mass white dwarf star. It is extremely unlikely that a white dwarf would be found at this close distance to an active star. It is far more likely that we see a brown dwarf in this image that is intensely activated in the high-density plasma sphere that typically surrounds a large active star, like Sirius is. Sirius is twice as large as the Sun and nearly twice as hot. In the plasma universe, any size of star can be formed with plasma concentrations, and have evidently been formed as we see it in the case of UY Scuti. The star is 1700 times as large in diameter than the Sun, which makes it 5 billion times larger in volume, while its mass is believed to be barely 10 times larger than that of the Sun. As one researcher has put it, the mass of this giant star is so thin that it is almost a vacuum. It is hard to imagine, even in mainstream cosmology, that a star with this extremely low mass density would be able to exist as a hydrogen star powered by nuclear fusion that is caused by gas compression. Only a miracle could cause that to happen, and to cause the resulting fusion, to make the resulting star 340,000 times as luminous as our Sun presently is, with only 10 times the greater mass. That's a miracle. In plasma cosmology, in contrast, no miracle is required for very large stars to exist and to operate. Under the force of large gravitational pressure at the center of a plasma star, the much lighter electrons in the plasma mix tend to become squeezed out of the interior of the plasma sphere onto its surface. When this happens, the interior expands by the force of proton repulsion that is less counteracted than by the diminished electron density, which exerts an attracting force on the protons. As a consequence, the star becomes larger. By this electric principle, the mass density of a plasma star increases towards the surface, which is the complete opposite of what we find in atomic mass concentrations that have their greatest density at the center of a sphere. With a plasma star having its greatest mass density at the surface, extremely large stars can form that have a relatively small total mass and still operate efficiently. Even in cases when the large sphere of a star is only able to achieve low-level plasma fusion, that gives it a surface temperature of a mere 3,300 degrees. The resulting large surface star becomes nevertheless a highly luminous star. It becomes this not by its own power, but because its very large surface area functions as a very large catalyst for interstellar plasma streams. This is how it is possible for a star with 10 times the mass of the Sun to outshine the Sun 340,000-fold, even while it is almost empty inside. The principle evidently also applies to our own star, the Sun. The Sun's mass density is roughly the same as that of the planet Jupiter. If the Sun was a sphere of hydrogen gas, its mass density would be 1,000 times greater, because of the gravitational compression at the center of the Sun. And Jupiter is twice as large in volume than Saturn. Consequently, Jupiter has double the mass density because of the greater mass compression, which both being gas planets. By this principle, the Sun should have 1,000 times greater mass density than Jupiter, because of its having 1,000 times greater volume. But that's not the case. However, with the Sun being a sphere of plasma that is largely empty inside, being essentially but a shell of plasma, the low mass density that the Sun is known to have is just about right. In its presently highly active state, the Sun's plasma shell is dense enough to support surface plasma fusion that heats it up to 5,800 degrees Kelvin. A larger Sun, by this principle, would have a denser shell with a greater electron density at its surface, which would enable higher surface temperatures, as is indeed the case. With the Sun being at the low end in the range of active stars, when the primal fields become disabled that focus interstellar plasma onto it, the Sun will have to work with what the unfocused interstellar plasma streams deliver to it. The resulting low-level default value appears to be in the range of 4,000 degrees or less. Some of the very large stars have lower default values that are nearly the same across the board. These values might be low because there simply may not be enough density in the default plasma background for the giant stars to achieve their full inactive potential. But this shouldn't concern us for the case of the Sun, which is far too small a star for such considerations. It is enough for us to know that evidence tells us that when our Sun goes into its inactive mode during the glaciation period, its surface temperature will drop to near the 4,000 degrees level, and it will become briefly reactivated in intervals of 1,470 years, all the way through the 90,000-year glaciation period. That's what the Dan-Scott-Ishko oscillations indicate that happened in the past. That's what also the stellar dynamics indicate, with a high degree to be totally possible, and will likely happen again in the future, as it has happened all the way through the previous glaciation cycle. This evidence that one sees presently rules out the white dwarf stage and the entropic red dwarf stage, but supports the type of inactive state at which the sun is being powered by interstellar plasma that is less focused on it because of potentially collapsed primal fields, and is less concentrated around it than it presently is, with a remaining surface temperature of around 4,000 degrees or less. That's the bottom line. This knowledge gained is the result of the extraordinary capability that we have as human beings to explore the principles that operate in the universe, and then to utilize our discoveries as a basis for building our future before it happens. The evidence prompts us to recognize that our star, the sun, is presently extremely vulnerable to reverting back to its low-intensity inactive state that had been the norm for the last 500,000 years that we have ice core records for, and that this event of getting back to the state of normal will likely occur in roughly 30 years, whereby the current interglacial pulse ends that has been our climate home for the last 12,000 years. With this consideration, we face the point where the academic significance of plasma cosmology gains a life-critical significance in the real world, because if the academic recognition is not sufficiently achieved to impel the relocation of most nations in the world into the tropics, together with new forms of agriculture and new cities, and this before the phase shift begins, then very few people living today, including their children, will have a chance to remain alive. The entire world becomes radically altered when the sun becomes a red star and joins the rank of the roughly 300 billion red stars in the galaxy, most of which are red dwarf stars that might have been once brightly active stars. The large volume of the presently inactive stars in the 4,000 degree range in surface temperature in the field of our galaxy is not really surprising if one considers that our galaxy is presently at its weakest state in over 400 million years. With measurements of oxygen-18 isotope ratios, which are climate sensitive, it has become possible to measure the climate history on Earth going back in time for almost 500 million years. The measurements indicate the existence of two very long resonance cycles that appear to exist in the intergalactic plasma streams that power the galaxy. These resonances together affect the plasma density across our galaxy. When NASA explored the galaxy in X-ray and gamma-ray light, two gigantic plasma domes became visible. These domes are amazingly similar to the electromagnetic confinement domes that are visible in plasma discharge experiments, which serve to immensely concentrate plasma streams at their node point. In this sense, the plasma domes come to light as galactic-scale confinement domes at the node point of two plasma streams with our galaxy between them. There, the plasma domes would be formed at the terminal end of two long intergalactic plasma streams, with each having a different resonance. The longest of these plasma streams would have a resonance that is reflected as the 145 million years cycle that has been discovered in the Earth's climate history. And the shorter plasma streams would have a resonance that is reflected in the 31 million years climate cycle. The different resonances would reflect the different distances of the interconnecting plasma streams between the galaxies. The weaker, shorter resonance would be overlaid at the junction at our galaxy onto the larger, long cycle. Both, in combination, affect the plasma density in the galaxy, and by reflection also affect the climate on Earth. That's what we see reflected in the Phanerozoic climate history. That in turn is likely reflecting the galactic plasma density history. It is critical to note in this context that both of the long climate cycles are presently near their minimal point. At their combined low levels, the modern Ice Age epoch began 2 million years ago, termed the Pleistocene epoch, with our galaxy being thereby at the weakest state in over 400 million years, and with it getting weaker still. It is not surprising that one finds 300 billion stars in the galaxy to have gone inactive already. In a few million years in the future, or tens of millions of years, as the case may be, when the galaxy has recovered, the presently inactive stars will then become active again, and may remain so for another 500 million years, till the next weak point is encountered in the galaxy. For now, however, the important aspect is the short-term timing. We need to know with a high degree of certainty when the coming phase shift starts, as our Sun joins the rank of the 300 billion inactive stars in the galaxy. As I said before, the phase shift will likely occur in the 2050s time frame, if not sooner. The solar activity cycles are already fast diminishing. The solar wind pressure is fast fading away. The climate on Earth has also been on a near-term down-ramp that began 3,000 years ago, which had trailed out into the Little Ice Age, from which the Sun briefly recovered, with potentially a dense-cord Ishka pulse. But with this pulse now ending, the final end of the active Sun is quite near. If the solar wind continues to diminish in the short term at the rate that NASA's Ulysses spacecraft has measured, the solar wind will cease completely in the 2030s. After that, the Sun itself will diminish until its innermost primal fields will collapse. At this point, it will become an inactive star and revert to the default level in plasma fusion intensity and become a 4,000-degree star. This may happen potentially in the 2050s, if not sooner, with a high degree of certainty. The timing is important because it determines the time we have left for raising up the value of our precious humanity in society's self-perception, in order that we may protect our existence before the most precious asset that we can possibly have on this planet, which is ourselves, becomes irreversibly thrown away as trash by neglect. Society is suffering a huge deficit in the area of its self-perception. Our humanity is not a trivial gem in the department of life on this planet. We are, by all accounts, the greatest gem that ever has lived here. We are the greatest asset on the earth that we can possibly have. We stand with a history of over 2 million years of development to our credit, which we rarely give ourselves credit for. We stand with remarkable achievements in our pocket: art and music, art, culture, science, technology, and humanity, each of which qualify to be termed amazing, extraordinary, if not miraculous. In the long sweep of the history of humanity, we are presently the last living species in the long train of human development. We named ourselves the Homo sapiens. We are the pinnacle on this course, but are also a child in the larger context. We have a mere 200,000 years to our credit. We are the 8th human species, of which the 7 previous species have all become extinct over time, perhaps in one of the harsh ice ages in the Earth's recent past. Even the most successful species of man, named Homo erectus, who has lived for more than 1 million years, has become lost and exists no more. We ourselves, after 200,000 years of development, have emerged from the last ice age as the sole survivor, with a world population of a mere 1 to 10 million people. This sparse human population on the Earth after the last ice age reflects to some degree the harsh conditions in ice age living. Today, we have a world population of 7 billion people with a richer culture than could have been imagined only 10,000 years ago. A culture with written languages, great music, astonishing art, architecture, literature, science, technologies, and the freedom to travel to any place on the planet in half a day or less. Human living has become an incredible marvel with an incredible experience that had never before been possible. We have succeeded beyond anything that had ever been imagined as possible. We can now see the universe that our world is a part of. We can even see beyond the leading edge, where the mainstream cosmology gets bogged down with epicycles and doctrinal concepts. We can look at our galaxy and its dynamics unimpeded, into realms that no one had dared to touch for a long time. By looking at the dynamics that are being discovered with the eye of the mind, we can determine the future that we will face before it happens. With the knowledge derived thereby, we can shape our world to shape the future before it happens, as we wish to experience it. Of course, what I propose as being essential, which indeed the evidence tells us is existentially critical, is not practical in the general sense of practicality, because the general sense of practicality has become hopelessly too small for anything to be accomplished. What I propose will most certainly be built, in spite of it being presently deemed impractical. It will be built because it is beautiful. The greatness of humanity is beautiful. Great works of art, of science, of infrastructures are beautiful because they touch a chord within where beauty is anchored. Beauty is the language of the heart. Truth is the language of the mind, and love is the language of the soul. With these unfolding as a symphony, civilization will flourish. That's what it means to living extraordinarily. No other expression of life can match the grand capability that we have for the extraordinary, built on small beginnings perhaps, but open to the stars, though we may never really fully utilize our potential as it increases even while we move ahead. Here, in our power to develop ourselves, lies the final frontier. We have contained in us such an amazing heritage that the gem that we have become is worthy of the greatest protection and the greatest nurturing and the most extensive development that is possible. But will we do it? Will we provide ourselves a future with the capacity we have as human beings? Ironically, we are prepared at the present time to throw it all away in a moment of rage. With 500,000 times the destructive force of the Hiroshima bomb all set up and ready to go, and with the war machine meticulously prepared, ready to become active in the time frame of a lunch break, humanity seems to have indicated to itself at the present stage that human life, after all, isn't worth living it, or else the nuclear war threats would have been erased long ago. Instead of removing the danger, the nuclear war threat has become ever more imminent. But all of this is artificial, a tragic, small-minded practicality. And being artificial, it can be overturned with the beautiful. Great steps have already been taken towards resolving the impasse of ugliness with dedication to the beautiful and the sublime. On this path, beginning at the grassroots level, both the nuclear war challenge and the Ice Age challenge will become resolved together, for both require the same line of progress to succeed, from the heart to the heavens. In this context, I had started to write 2 novels back in the 1980s as an exploration of how we can get ourselves out of the political trap that had become terribly treacherous even then, and uplift ourselves to our inherent human potential. The 2 novels that I had started then and eventually completed were designed to raise our awareness of human living as the most incredible experience of life, and to raise it up further to it being exceedingly precious, which it is. Then, even while the work was being completed, as if this was not enough, I had started another novel in the early 1990s that became a series of novels to explore the principle of universal love with the focus on gaining greater freedoms to love one another as children of a common humanity. With a focus as wide as that, the project ended more than a decade later as a complex of 12 novels with a single story threaded through the whole. My point is that if we don't make the grade on this line and recognize the great value that we have in one another as children of one single humanity that exists on our planet, the long-prepared-for nuclear Armageddon will succeed and unfold one tragic morning, and by noon the deed will be done that renders the earth a lifeless rock in the wake of great ensuing agonies, and renders the miracle that we have developed in ourselves wasted. The danger is real, that we may lose everything. The ancients stand ready for the button to be pushed. No one will ask afterwards, what was it all for? Nor is this question being asked today, because no rational answer can be given. And tragically, no headway has been made in 70 years towards getting out of the trap that humanity has set for itself. In the same careless manner is the Ice Age danger being brushed aside today as if it was irrelevant, which, in contrast, is the only danger that is not artificial. In facing the Ice Age challenge honestly, which is immensely imperative, we may open up the potential in our heart and mind and soul to heal all the lesser great challenges that have overcome our world already, with ever darker times on the horizon as the world's financial and economic systems break down under the growing weight of speculative looting instead of cooperative creating. The Ice Age challenge by itself is not a difficult challenge to meet physically. It can be met with floating agriculture and floating cities strung along the equator. However, the footsteps involved are immensely wide in scope, so that they require the cooperative unity of the entire world to master the challenge. The Ice Age challenge is always global. No one on this planet is ever not affected by it. It reaches beyond politics, national, regional, or ethnic concerns. The challenge goes to the very center of humanity, with the imperative for the world to stand as one for one another without exception. We have no hope on any lesser platform on the Ice Age front, and by implication on any lesser front. With our responding to the Ice Age challenge and its imperatives, with the grandest of all that we have and are as human beings, we would write ourselves a ticket for building the most sublime and livable civilization that ever existed, with ever more amazing human experiences along the way as we become one with the universe and one another. We stand tall as human beings on this platform. We stand at the harvest gate. We also know that with each harvest begins the seed time anew. Seeds are we, wind-blown by our own wind, carriers of secrets still unknown, poems in the words of nature, of our human nature, sentinels of an intelligence yet unseen, prophets of the enduring, apostles in an endless landscape. Seeds are we, wind-blown, poems in the words of nature, sentinels of an intelligence yet unseen. Harvest is seed time, thoughts ripening, carried as by a great wind, carriers of secrets to unfold, thoughts winged with purpose, a force waiting, silent, patiently ready for the moment. Harvest is seed time, thoughts ripening, carried as by a great wind, carriers of secrets to unfold. Thoughts to awaken, roused by the moist warmth of spring, cascades of colors, colors of life, bright yellows, bursts of silver white, thoughts becoming creations, monuments of genius, builders of worlds. Cascades of colors, colors of life, bright yellows, bursts of silver white, thoughts becoming creations. Who owns the seeds? Do we? Who can fathom their wonder? Life flows from them in great rivers, rivers trailing into oceans. In them we are alone. Each one is alone. Each thought is sovereign. Beauty is its song. Who owns the seeds? Do we? Life flows from them in great rivers, rivers trailing into oceans. Thoughts are seeds becoming ideas, alive in discovering, alive in listening, alive in being touched by love, alive in loving, alive in listening, alive in being touched by love, alive in loving. Like seeds, thoughts fall to the ground. Potentials are lost. Hard ground kills the precious. But we are men. Hard ground becomes tilled, watered. The precious is nurtured in loving. Hard grounds kill the precious, but we are men. Hard ground becomes tilled, watered. Love for one another, the human spring. Mankind is afloat in a seed that is love. Seeds germinate, become plants. Roots break the ground. Love lifts the barriers, patiently, silently waiting, reaching for the sky. Roots break the ground. Love lifts the barriers, patiently, silently waiting, reaching for the sky. Thoughts are the universe unfolding, landscapes of brilliance, ideas of power, substance for enriching one another, substance of the forever maturing. Thoughts bearing new seeds within, seeds for splendors beyond dreams. Landscapes of brilliance, ideas of power, substance for enriching one another, substance of the forever maturing. Each harvest is seed time. A seed becomes a plant bearing new seeds. A thought unfolding bears up civilization. A spark in the heart bears the fire of life. New worlds are created in the fire of passion. We are the bearers of a fire that is light. A thought unfolding bears up civilization. A spark in the heart bears the fire of life. New worlds are created in the fire of passion. Builders of worlds are we. New worlds which have never been, precious with riches grander than our own. Nature is love reflected in loving. Love points with the colors of its endless spring. Love paints us all, but who owns the seed? Precious with riches grander than our own. Nature is love reflected in loving. Love paints with the colors of its endless spring. Who owns the cradle for the seed? Name it intelligence, name it the universe. Thoughts are seeds from an infinite fountain, monuments of grandeur of good. Fields of flowers dancing in the sunshine. All nature whispers this to us. Thoughts are seeds from an infinite fountain, monuments of grandeur of good, fields of flowers dancing in the sunshine. The melody of nature, what a song! Whispers of a splendor grander than the heavens. Like seeds are we whisper too. seeds bearing gifts for the world, gifts wrapped up in sunshine. Gems are we, unfolding a majestic song. Whispers of a splendor grander than the heavens. Like seeds are we whisper too, seeds bearing gifts for the world. Listen to the song, listen to the heart, listen to the silence where strands of love unfold. Listen to the symphony of our humanity. In this symphony we are one, one with the universe itself. Listen to the song, listen to the heart, listen to the silence where strands of love unfold. Listen to the symphony of our humanity. In this symphony we are one, one with the universe itself.